Hi, I'm Scott Hanselman. This is another episode of Hanselminutes. Today I'm chatting with Kent C. Dodds. You can check out his website at epicweb.dev. I'm going to start that again because I misspoke
Sure.
there. Starting over, Mandy. Hi, I'm Scott Hanselman. This is another episode of Hanselminutes. Today I'm chatting with Kent C. Dodds. You can check out his website at epicweb.dev. How are you, Kent?
I'm doing great, Scott. It's just an honor to be here. I'm super happy to be here.
I don't know. Honor is a very big word, but I appreciate you being here, and I'm always a fan of your work. I love seeing you speak. I love seeing you interact on social, and I got to see you at All Things Open in Raleigh, North Carolina, recently, where you gave a keynote and you talked about the web's next transition, and that's a big statement. You think something big is happening in the web space?
Yeah, I do, and it's not Web 3 or Web 5 or any of those, so maybe not quite that transformational. But as far as the architecture of the majority of web apps that developers are working on, we definitely have had transitions or eras of different architectures that people have been working on with web apps. So, yeah, I'm seeing a new transition, and I'm really excited about it as a web developer myself.
Yeah, and I think it's interesting. Maybe you intended this, maybe you didn't, to have called it transition because the transition that you're talking about is transformational. It's giant,
Hmm.
but it's also the transformation and the transition between pages. I don't know if that was an intentional use of the word transition.
Yeah, that I should definitely take advantage of that pun. That's for sure.
Yeah, yeah. So, when I think about the web, and I think this is somewhat generational because, the web that I grew up on in the 90s was there's a page, you interact with the page, and then you post, and then you go forward, and you either post or get to make your way forward. And when I came up as a web developer, we had a thing called post, redirect, get. Right? You do a post, you act on the post, and then you redirect to the result of that thing, which that redirect then results in a get. And you're kind of
Mhm.
ever moving forward. What is that? Is that a standard pattern? Post, redirect, get? Is that the pattern that most pages use?
Certainly not what I would say most pages use today.
Hmm.
And you actually can see that even with sites that implement more traditional architecture of multi-page apps, where anytime you see like an airline is a good example of this, where they say don't hit the back button in the UI, and then if you do, you get this confirmation dialog that says, "Do you want to confirm resubmission?" And what that's saying is they didn't redirect after the post. They sent back HTML as a response to their post, and the browser can handle that, but that sticks the post as part of the history stack. And so if you hit the back button, it has to resubmit the post to get the same HTML.
That's a really, really interesting point. I want to make sure that we hit that hard. So you're saying that if I'm on a website and I hit back and I get the warning that I'm about to resubmit this, that's probably an architectural flaw, or that is
Mm.
an architectural flaw in that web's design.
Yeah, yeah, exactly. And often you will see like the developers or designers put a page in there or some text that says don't hit the back button. And if they just went a little bit further in their understanding of what's going on, then they would know the post redirect get would be the solution to their particular problem. They wouldn't need the text, and the browsers wouldn't need the confirmation dialog or anything like that. You just instead of sending back HTML from your post, you send back a redirect and send the user to the next place that they're supposed to go, and then they don't get that in their history stack. It would have really simplified things for everybody.
Okay, so post redirect get, while not the way that most apps are done today, it was real common in what you're calling MPAs, or multi-page apps. Is that
Hmm.
fair?
Yeah, I would say, yeah, and honestly, I actually do think that it was very common, and we just are suffering from the few who do not implement things that way, right? But we notice the ones who don't do it a lot more than we notice the ones who do. But like, as far as like that as a pattern that's widely used, it's probably not because most developers for web applications are building single page apps, and so the like as far as post and get and delete and all of that, that's all just happening with like fetch requests that people are making. We're not doing full page refresh type of or browser serializing the form type posts anymore.
So you call out in your article that we'll link to in the show notes this transition as we move from multi-page apps to apps that are multi-page but have sprinkles of JavaScript up to single-page apps, which you just asserted are the most common apps, and then the next transition that we'll get to. I would argue that I think that there's a lot of these progressively enhanced multi-page apps, these JavaScript sprinkles, where people have an existing multi-page app architecture and they add a little list.js to make sure that you can get some auto search or whatever. The Hanselminutes website is a JavaScript sprinkles app. How do we measure this? How do we know what the most common web architecture is? Is there a way to spider that?
Yeah, that's a great question. And people will take issue when I say that spas are the most common that developers work on because they think of it in terms of deployments of a particular architecture. And I'm actually talking about it in terms of active development, like what developers are spending their time on. And that's very
Mm,
different.
I see.
So, like, a good example of this is if I were to say, I build a library that uses the bitwise operator. Like most JavaScript developers don't even know what the syntax for that is or what even that feature does. But then I get that library into WordPress, and now all of a sudden I can say that like the bitwise operator is used on 90% of the websites on the web, but like nobody knows what it is. So there's a distinct difference between the deployments of a particular architecture and the ones that developers are working on actively. And so that's as far as actually measuring it, that's very, very difficult to do. But and so to be clear, I have not. But I would be very surprised if we categorize developers in the amount of time that they spend in each architecture. I'd be very surprised if we found that SPA was not on top by a large margin.
hmm Okay, so then spas, single page apps, these are applications that load up some template. We see that loading screen that we see on things like Facebook Messenger, where it's like a bunch of gray boxes, and it's like this sense of like here's kind of the skeleton, the scaffolding of what this is going to look like. But the app is now a client side JavaScript, whole universe. All of the navigation occurs on the client side.
Exactly, and it's like a native app that's downloaded on demand. And that were what always bothered me was that we're okay with native apps being many megabytes that take many seconds or even minutes to download and install. But in the web world, if that thing is more than a megabyte and it takes longer than a second to download, like it's totally not okay. So there seems to be an unfair standard here, but the fact is, like, our users do expect to be able to go to our URL and get the entire experience very quickly. And in some contexts, that will impact you in an enormous way, like especially e-commerce. In others, maybe not so much because the user's boss is the one who paid for a license, and there's no other software you can use. So that a lot of times in the web world, we talk about performance as it's the most important thing, and that's absolutely not the case. It is not the most important thing for every single app. Different things matter more for different apps. But what would be cool is if we could have some tools or an architecture that gives us that performance as well as the other things that are important for 90% of apps. And so that's what this architecture I'm talking about kind of offers.
Yeah, it feels like a lot of sins are hidden by the installation part of the application in the life cycle. So if I have an iPhone and I go to the App Store, I could download 100 megs, I could download 5 megs. We never know because an icon appeared on my screen and I stopped thinking about it. So
Mm.
that tax was simply installation tax. But on
Hmm.
the website, visiting a URL is an implicit quote unquote installation in the sense of you'll start getting permissions requests and you'll start using browser local storage, but no one ever really felt like that. So you think, well, I clicked on the icon. Why didn't the website launch instantly? So you're right. There
Hmm.
is a total double standard there where we hide all kinds of horrible things in the installation phase of an app, but websites don't get that same affordance.
Yeah, and part of it too is that apps, they can update in the background. So anytime there's a deployment to the new version of the app, that'll just update when the user's not using it and everything's all set. Whereas websites, they don't update in the background. You update it on your server, and then the next time the user goes to that URL, they download that app. and get that updated. And if you want to have some sort of update in the background, you have to implement that in application code. There's not really a good way to do that. And on top of that, the user like won't get the update until they open it up again, and then you have the little pop-up that says, "Hey, we downloaded a new version of the app." Like it's a very different set of constraints that we're
Yeah.
working with in the web.
And we'll certainly be fine with someone having a big giant MP4 video as the background of their website, and we'll put up with a 10 megabyte video or a 5 meg PNG. But if a JavaScript library takes more than a second to load, we're like, this website sucks.
Yeah, there is a difference though. That's an important distinction between a megabyte of PNG versus a megabyte of JavaScript, because the PNG is very, browsers are really good at rendering those fast and everything. JavaScript does have to be executed, like parsed and evaluated, and so there's certainly a bigger cost to that, and even 3 lines of code can add a very significant cost to processing power for a device as well. So it's not apples and apples, but yeah, it is kind of funny that we do throw a big stink about sizes of things, and this happens a lot actually in for web developers in particular, when we're talking about performance, where we say, let's shave off 5 or 6 milliseconds over here, when you could just like change your infrastructure a little bit and save 500 milliseconds over there. It's just kind of interesting. And I think in part, this is because a lot of front-end web developers don't feel empowered to make those kinds of savings from an infrastructure level. And so they are just working with what they have, and they'll save 5 milliseconds on their rendering times.
That's a great point. Let's go through in these architectures. There's basically these 6 use cases that you've identified, and I think that they're pretty interesting because we can think about them in the context of what we've already written. So our listeners can be listening and say, "Oh, I know what I used for that." Or if they're
Mm.
an app developer, these apply to app development as well. So you've got persistence, that's saving and reading data from a database. That can be on this client or on the server, right?
Sure. Yeah. Typically, in web, it's going to be on the server. Most of us who are building an app, a web application for money, that application is using persistence on the server. There are a few of us who are making games and things, but yeah, most of us, it's going to be on the server.
Right. So for the average Joe or Jane who's listening, other than Wordle,
Yeah.
which is doing some pretty clever persistence on the client side, saving and reading that data is going to be from the database, and that's where you'll have your web APIs and your microservices that are going to be doing that persistence for you.
Hmm.
Okay, and then routing, which I'm very, very familiar with on the server side, but I'm understanding is something that can be very powerful on both the server and the client. What is routing on the client so important?
Yeah. So when we're with the original architecture for the web, you get full page refreshes between pages, and then push state came around. I can't remember when that was introduced in the early 2000s, and you were able to change the URL without triggering a full page refresh of the browser. And what that gave us was just the ability to build highly interactive, routable applications without talking to the server, making it seem or feel a lot faster in many instances. And so a client-side router will be responsible for giving most likely a declarative API for saying, here's the URL and here's the UI for that URL.
Okay, and that's really important. Like, so for folks who have been doing web development for a number of years, but maybe haven't been doing modern web development, the UI and the URL are indistinguishable. Like that URL matters.
Mm-hmm.
You don't just want to put crazy GUIDs and stuff in your URL anymore, and you have full control of what can appear there. And it may not reflect server-side reality. It's a piece of application state.
Yeah, it really. It, in the modern architecture that I'm talking about, it is reflected in both the server side reality and the client side reality, because it will server render at that location. But yeah, for like spas and things, for a lot of people, they land on any URL and they just configure their CDN to send their index HTML back to the client. Call every URL a 200 status code, and then let the UI display whether it's a 404, which is very problematic for various reasons. But yeah, so there you can take this to varying degrees of extremes, I suppose.
Well, you just gave that quick example of like you pull in a index.html and then let everything happen on the client. There used to be a single page wiki application that was just like one super index.html that we would use for a TiddlyWiki, I think it was called.
Hmm.
Um, when someone says a single page app, are you literally saying that there's one index.html, or you can decide to chop it up however you want?
Yeah, that's interesting. So, like in the early days of single page apps, it was just one index HTML. You would configure the server to just always send that, and then the client could take over from there. In the last 5 years or so, static site generation has become to be really popular, and we had static site generation for a long time. Like you had your like GitHub Pages is a good example that a lot of people are familiar with, or Jekyll or things like that. But the more modern static site generation allows you to take a web application that you're using front end technologies with, particular React or Vue or something, and generate the UI or the HTML for all of the pages of your app. This is not practical for many use cases, but it is practical for some. But in any case, you can generate those HTML files and then send it up to the CDN, so that when a user goes to kentcdodds.com/blog/ aha programming, it can send that HTML document that was pre-generated. So that way you don't have to send just a loading spinner while we go and load the document. But there are a lot of shortcomings to that as well. And I still lump that in as a single page app because when that HTML document loads, whatever HTML document you got in the first place, from that point forward, you're not requesting any more HTML from the server. You're just event prevent default on links, event prevent default on forms, and you're hitting APIs with fetch requests and stuff like that.
You say this prevent default. You say it really quickly. Let's break that down a little bit here. Prevent default is what?
So with the browser, since the very beginning of the standards over 25 years ago, the browsers had anchor tags, and which is links between pages, and forms, which allow you to have for or fields where you can input some values and then submit those, and the browser will serialize that into a post body, or for example, or serialize that into a query string for the GET request and send that to the backend. So you have the ability to transition between pages and to make data changes on the server. And that the default behavior of the browser was to do a full page refresh between every single one of these links that you click on, every form that you submit. You're going to get a full page refresh as a part of just the way that's architected. Um, and so when I say event prevent default, what I'm referring to is the desire that we had to not have this full page refresh because for various reasons. It's just difficult to manage UI the feedback as far as spinners are concerned. You have very limited ability to do inline mutations. Like if you had to do a full page refresh for every tweet you favorite, that would be a real big problem. We wouldn't favorite as many tweets, and whatever other things. So like we just for various reasons, we don't want to have that full page refresh for modern apps. It just doesn't feel like a native app. And that's what we're always trying to emulate on the web is this native app like feel. So we prevent the default behavior. When a link is clicked on or a form is submitted, there's an event that's emitted before that actually takes place, the full page refresh. And so we can hook in and say, hey, actually, never mind, prevent the default behavior. I'm going to take care of that. And if it's a link, then we'll say, here's the URL that link was to. Let me pass that off to the router, and then the router can take care of making the UI show up that's supposed to based on that URL. If it was a form, then we're going to prevent default, and we'll take the form data ourselves, serialize that, and do a fetch request that sends JSON to some API or something. That's typically what most apps, SPAs, are doing today.
All right, perfect. So that brings us to data fetching and data mutations. We talked about persistence, talked a little bit about routing, data fetching, retrieving data from persistence, and then mutation of changing it. So that's the read and then the write. So clicking on an anchor tag on an Ahref is a navigation by default, and clicking on a button is a form submission or a no-op, depending on the kind of a button by default. You prevent that default, act upon it, and then you have code on the client side do the thing
Hmm.
without leaving, and there's no navigation. But then to your original point about routing, you can click that button, retrieve something, and change the URL if you wanted to. So the
Hmm.
user feels like however you want them to feel. We really do have full control over the browser experience at this point.
Yeah, and unfortunately for us, the browser's default behavior is more complicated than it seems, especially when
Mm.
it comes to the user clicking various links all in quick succession. And there are race conditions involved in that. And it's very difficult to reproduce those because normally our server is running on a machine. You're not going to run into race conditions. But in the real world, traffic is going to go to who knows what through what routers and things. And so race conditions are a real problem, and the browser managed those automatically for us. And when we prevent default, the next lines of our code is just emulating what the browser was going to do, and we just don't do as good a job at that typically, which is a shame.
And you used a really interesting example that's worth digging into. You said like favoriting a tweet, or you're on an application and you want to bookmark something. If you clicked on that, waited for it to change data in persistence, and then do a get and confirm that it in fact happened, you might not be able to just go fave all the way down. So it's totally appropriate, I guess, to fire and forget and let it work it out later.
Yeah, sort of. The challenge is so what Twitter does is they implement a pattern called optimistic UI, which will update the UI to be what the reality will be, assuming everything goes okay. The challenge with that's not too difficult in itself, but the challenge comes when one of those tweets was deleted or something like that. There's some sort of failure that happens on the server, and rolling back that U update, and that's where things get really tricky. And a full page refresh, that's not a problem because it does a full page refresh and that tweet is now gone, and it wasn't favorited. So like you don't really think about that sort of recovery in that scenario. But if we're doing this in with our own fetch request, then yeah, we need to start thinking about how do we roll these things back. And as far as fire and forget is concerned, like if you did that, then you wouldn't be able to recover. So you do have to acknowledge the response that comes back, and update the UI in some way. And the spot architecture makes that reasonably possible, as well as the progressively enhanced multi-page app architecture. But is definitely a challenge, and the architecture we're transitioning to drastically simplifies that.
Okay, so then to that point, you have this really great sentence in your article, "The Web's Next Transition." Again, I'll link to that in the show notes, where you say, and you're basically talking directly to me. You say, "Folks who have been through the MPA stage, the multi-page app stage, and are working in single-page apps, truly lament the simplicity we've lost in the last decade." And if we could somehow merge the two, we could make something that is both simple and more capable. And that's what you're promoting. That's what you're quote unquote selling to kind of like web developers out there in the world. So what is the best of both worlds?
Yeah. So to review, we started with multi-page apps, and then we went to JavaScript sprinkles. I call that progressively enhanced multi-page apps, and then single-page apps. And now we're moving into this is an observation I'm having in the web. We're moving into progressively enhanced single-page apps, where um, progressive enhancement is about having a baseline of a functional app and then enhancing it with JavaScript sprinkles, making the experience better. Spas kicked that to the curb and said, you know what, this code duplication that we're having with having to make the app work functionally and then adding sprinkles, and there's a lot of code duplication in those sprinkles, depending on how far you take that. And so because of that duplication, we just decided, let's delete all of that code on the server, and now we kick progressive enhancement to the curb. The app does not work as a baseline. We need to have these special features in the browser for this to work. Progressively enhanced single page apps say, no, 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 we can actually have the baseline functional app with the most basic features of the web, and then layer on a little bit of extra functionality, and still avoid the code duplication by sharing the code between the server and the front end. So the same UI code that generated the page on the server is going to be used on the client to handle page transitions and make sure that we update the UI based on whatever data changes there are. So we can sidestep the problem that we had that led us to spas in the first place, of that code duplication, by just using the same code in both places.
Okay. So that you say in your article that the server code needs to work the same way regardless of whether the browser is making the request, via on its own, or whether some JavaScript-based fetch request is being made. And then
Mm.
we get the benefit, you say, of sharing code on the front end and the back end. Does that not imply, though, that that means Node is the only answer, that a JavaScript-based system is the only answer? What about people who want to use PHP or Ruby or Blazor or C Sharp or whatever, if you can't share the code on both front end and back end?
Yeah, that's a great question. Think about this architecture as more of taking. So you may, if you're that in that position, you probably already have an existing backend, but with whatever language you prefer. But then you have some JavaScript sprinkles, just because that's the way that the world is. You've got to have that. So instead of thinking about, okay, well, we're going to get rid of our existing backend that we like, so that we can have this architecture that shares code on the front end and backend. Instead, just think about taking that front end code you have and shifting it over the network just a little bit, so some of that is going to run on the server. And there are various deployment or hosting strategies that you can do for that. Most CDNs support running JavaScript on the edge on those CDNs. Or you can have, this is what we did at PayPal. We didn't implement the PESPA architecture, but we did, or the progressively enhanced single page app architecture. But we had this middle tier node layer that we used, and that talked to our downstream Java services. And so, however you want to do that, you can keep your existing backend that you like for all of your backend logic and stuff. But that backend probably wouldn't be involved in any UI. It would just be APIs and things. And then you take your existing front end UI and shift it over to the server just a little bit, so that you can have everything rendering on the server. Ultimately, this gives you a much better developer experience, as well as a much better user experience. And that's the goal.
Interesting. And you bring up a really powerful point that I think I want to make sure that our listeners don't miss, because classically we talk about the client, we talk about the server, but you just introduced a new actor, and you called it the edge, and then you called it a CDN, but the acknowledgement that it's not simply the user's browser and some endpoint server that we terminated on. There are multiple stages, and a CDN, which is historically returns static content, returns graphics. Why couldn't it run a, I don't know, mustache template, or render
Mm-hmm.
some, combine some stuff? It's doing interesting work already. It's a perfectly cromulent place to do work if my back end doesn't want to do that. That's a revolution right there.
It really is. It's really exciting. In these types of scenarios, your the code that you do run needs to run very, very fast. Typically, like Cloudflare, you need to have it run in a handful of milliseconds, as an example. Like, these CDNs don't want to be mining your Bitcoin, but typically, like most UI rendering is going to happen very fast. So the heavy lifting is whatever data stuff you're doing in your backend already. And so, yeah, these CDN or edge environments are typically pretty constrained. Though I personally really like using a service called fly.io. That's where I host my personal website. And what they do is interesting. So rather than taking a network of hundreds of servers all over the world in their CDN and making it so you can run a little bit of code on there, they allow you to distribute an entire server, a long running server in multiple regions all over the world. And it can be written in any language that you like. Mine is all in Node. But that has worked out really nicely for me and the whole goal of all of this, of course, is to push our execution out closer to where the users are, so they don't have to cross the Atlantic or the Pacific when they're trying to get data and the UI for our apps.
That's also a really fantastic point that you make there, because the client server architecture historically has been quote unquote dumb terminals, where those dumb terminals might be in the 80s, where it's just a screen that knows how to put strings on a green screen, or it might be a dumb-ish terminal in the form of a really old browser and a very constrained local process. But we have pocket supercomputers now, and every phone, even the cheapest Android, has some power on it. So you said push some of that processing out to the users. There's processing power as you get towards the user. How much work should that low-end Android phone do? Does a PESPA, a progressively enhanced single page app, have the ability to express, like, I don't think my phone is really good at that. Or, hey, this high end iPhone, let it do more work. Could you progressively enhance based on the power of the client?
Yeah, I think that you could. I haven't seen anybody do that. That's a very interesting idea, but I believe that at least I'm thinking about it in the context of Remix, which is the first implementation of the
Hmm.
PESPA architecture that's being followed along by Next.js and Solid Start and SvelteKit. They're all following the same kind of patterns, trying to get to the PESPA architecture. But in the context of Remix, I do believe that would be possible, which,
Hmm.
yeah, be an interesting experiment for sure.
Yeah, it definitely shows us that this is a beginning of the web's next transition. Of course, Remix, you can see at remix.run. It's a full stack web framework that lets people think about maybe doing some of that work not on the server, a little bit closer to the user. And your new, Kent, your new venture is epicweb.dev. You're doing this full time now?
I am, yeah. So full disclosure, I was at Remix for about 10 months. So I was working there.
Hmm.
They were, I left to go full time on epicweb.dev a few months ago, and they were just acquired by Shopify. So congrats to them. It's exciting
Cool.
for the framework. But yeah, my focus for a long time has been education. And I've really wanted to build what I always called kcd.edu. Everything that I know about web development in one place. And so that's what Epic Web Dev is going to be. It'll take me like 2 years or more to make it, but I'm working on it actively now.
That's very exciting. Folks can go to epicweb.dev and you can sign up for Kent's mailing list. And he's creating a series of workshops where he's going to have you building authentic examples, really focused on learning outcomes. And it's not a boot camp, it's the hard work of real world web development,
Hmm.
hosted by you, Kent C. Dodds.
That's it. Yeah.
Very cool. Well, thanks so much for walking me through the web's next transition. I appreciate your time today.
Thank you, Scott. Really appreciate all that you do.
This has been another episode of Hanselminutes, and we'll see you again next week.